Hey everybody, this is Larry. This is Weekly Contest 411. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. We have 30 seconds to go on this contest. Hopefully this one goes a little bit better than mine. Not just for me, but for Leetcode, because I feel like their quality has been kind of... the prompts have been good, but the quality assurance has been kind of bad with a lot of poor test cases stuff. So hopefully this is a good contest for them and not have as many, random issues. But yeah, let's go. 8 seconds to go. Very excited, I guess. Let's go, go, go. Go, go, go. Ooh, ooh. Did I not register? I registered, right? Yeah, okay. I start? Okay, yeah. How many double problems? Only one double problem. We'll have to go back to it. Okay. Yeah. Number of 0 in a string. Or is K? So okay, with K is equal to 1. Oh, every except for these. That's a very weird thing, but okay, fine. Let's just write it in the dumb way. I know that this is a thing, but at most, right? Five. Number of zeros in the string is at most K. Huh. I misunderstood this part. Huh? How am I so slow in this one? What is going on? 13? Oh, either, not both. Okay, man. I definitely misread this one clearly. Okay, now we're undercounting. I mean, now we're overcounting, but why? 15? Because basically I'm doing all of them. If zeros is... Why am I reading? I have some trouble with reading. 0 is at most K. Number of ones in the string is at most K. Why is this not right? 101 is not right, right? Well, 1010. So we're not putting anything, so why? Man, I am bombing hard. Is it a string? Am I being dumb? Okay. I just woke up, so yeah, okay. Yeah, that was silly. I just woke up and I'm a little bit tired from it. Okay, so we could do Q4, but it's fine. Let's just do this one for now. Okay, energy A, energy B, same length. It's for time. Well, now the constant system. We don't maximum. What does A mean? per hour is a little bit weird, but okay, I see. It's given each hour. Okay, yeah. Okay, yeah. I wrote this in a weird way. Fine. Let's just not. I prematurely optimized. Is what I did. Yeah, this should be a for loop. -1. Huh? Oh, whoops. Whoops. 5 and 8, 7. Oh, whoops. This is 2. Copy and paste error. No silly mistake, please. Oh, silly mistake. Oh no. That's not good. This is already a terrible contest. Why did I get 34? Am I wrong here? I am dumb. No, that's right. No, that's wrong. I am dumb. Yeah, okay. That's a very subtle mistake. I don't know if it's that subtle, but I made it anyway. Okay, well, no one's getting the first two. I have a 5-minute penalty, so that's a little bit tough. We have 2 hard prompts. It's a 6 pointer. Okay. 6 pointer is more like it. I am. Okay, so let's focus. X is a palindrome and divisible by K. N could be a really big number, huh? K palindromic. And we don't even have to consider the even case. Let's skip ahead real quick. No one's gotten this one either. I wish I got Q2 correctly. faster and also Q1 faster. This is going to be a disaster. Can I do Q1? Are these the same problems? Let's double check real quick. Because... okay, there's a query. Okay, so they're not the same problem. Seems much harder actually. Okay, so they're not the same problem. Okay. Which one is easier? I don't know, to be honest. This is gonna be a disaster. Okay. Okay, I think this is case analysis. K is equal to 1, then we just return 9 times n, right? If k is equal to 2, then we have 9 times n minus 2, so like a 8 plus... is it 8 or 0? No, it's 8 because you want to... so 88 is... okay. Right. Just want to make sure that this doesn't crash. Let's say 102. Okay. I think this is right. Okay, so I think this is the same way. Then k is equal to 3. If not, anyway, no one's gotten it yet, though. I don't think I can be that smart. 3 is tough, though, so maybe because all the other ones are tough. Okay. Can the last digit be 9, right? Yes, that's the thing. I guess it's just brute force on the last digit of 3. Alright. It's just would take time, I think. I don't think it's that hard, but okay. Maybe. So we want to... can 9 be the first number? Nine cannot be the first number only if n is equal to 3. No, it's just all 9s, right? It's just always gonna be 9 times n. That doesn't make sense, yeah. K is equal to 4. Now we have zeros. That's not great. You have 96, okay, no. So you have 8, you want 8 to be a beginning. 88 is good, but that's not the maximum, right? So we want something like, this is not really good. 88 would be good, but what if we have, can 898 can be good? No, right? So 888 is good. 898 divided by 4 is not good, so 888. And then we have 8998. Nope. So then it's 8888, and then now 89998. Nope. 89998. Maybe it just always is. Okay. Let me see. For I in, let's just say 20, just for science. If 8 plus 9, let's just say 2. Yeah, whatever, times I plus 8. So int of this mod 4 is equal to 0, print good I, just gonna do it at 1000, why not? Oops. Return 8 times n, right? So then now we have, let's say 1004. Okay, so that means that, oh, good is 0, but 0 is no 8, so that's why. Okay, so that means that I'm good with this one. 5, the first digit has to be 5, and then it's just 9s, right? So I think that's fine. I think I have to also do if n is equal to 1. Because, yeah. Because I might, this would just be wrong if n is equal to 1. And it could be 1, right? N could be 1. So if it's 1 and 2, then we just want 8 and not 88. Yeah. If n is equal to 1, then we return 2. Oh, no, 8. N is equal to 3 is fine, okay. And same idea, if n is equal to 1, then we return 1 5, otherwise we return 2 5s. Okay. 6 is going to be trickier. I think 8 is also the same number of 4, because why not? Let's try it. No, yeah, it has to be even, so okay, so let's do and we'll skip 6 for now. 7 is going to be tricky as well, so 8 is good as well. At least we don't see anything, so that means that, yeah, 8 is good. 6, 7, and 9. Whatever, we write it. 6, right? So 6. Well, we still want an even number. So, okay. Does that work? Okay, let's try this thing. This is just a guess at this point, honestly. Oops, this should be an 8. Oh yeah, why am I having a 60? This is the thing that should change. Okay, so 8 is actually also very good for 6. Okay. 9. 9 is a little bit tricky. No, it's not. It's just 9 times n. Right? So then now we only have to do 7. 7, can we do 9? Yeah, let's try 7. Okay. 4 people have gotten it. I don't know what that means yet. Okay, 7 is the tricky one, I think. Right? 99 is if n is equal to 1. Do we have 0? No. Then we just return 7. Otherwise, 2 is going to be 91? No, 98? No, 98 is not a palindrome laddering. 77? 3 number is going to be, is it just 7 times whatever? 797 divided by 7 is no good. 787 divided by 7 is no good. So then it's just return 7 times n? Is it that easy? I really need to keep this up. I keep on removing it, but if int of 7 times 7 plus 9 times I plus 7 mod 7 is equal to 0. Then print good 7I just for science. Okay, so that means that there are good 9s. That's not good though. Well, it's good in that we see a pattern which is every 6, right? But then now it's like, okay, well, 7, 9, let's say it's 5, right? 7, 9, 9, 7 divided by 7 is not good, but 7, 9, 8, 9, yeah, 9, 7 divided by 7, 7, 9, 7, 9, 7 divided by 7, 7, 9, 6. Okay, so for I in range of 7, how do I write this? So I want a 5-digit one, right? Seems like 7 is going to be a tough case. Okay. Or what about just 4 digits? Now 4-digit is either 7997, which is no good, 7887, which is no good, then we're good, right? If it's even number of digits, is it always... Well, no, because it's 6, right? So then 6 is even. So 7999 is... So we want odd digits. So let's just say... how we want to write this? -1 to 700, right? If I plus this could not include the first string, so well, something like that. So there are no good possibilities. Let me also just run this real quick. I guess I just did this loop well. It's been a while. Okay, 7997. Okay, good is 795. Which is not good for me, because that means that there are a lot of examples. Okay, well, let's fix this first, which is that if n minus 2 mod 6 is equal to 0, then we return 7 plus 9 and minus 2 plus 7. Right, okay. Now we have to think about this one. 795. Wait, what? Oh, because we terminate this early due to... Wait, is that what we did? How come we don't print here? Oh, because this is... yeah, okay. Okay, so then here we have so 795. I guess by definition, one of these numbers have to do it, right? So that means that all we have to do is just brute force the last digit for the middle digit, because it's every 7 numbers. Okay, yeah, you got it, I think. Okay, I just got rid of my test cases, but that's fine. Also, it's possible that I'm gonna have like 5 wrong answers on this one. Also fine. But yeah, okay, so then now we have 7 plus 9 times, let's see. So if we have 5 digits, we remove 2 of them. We have 3 digits, so it's n minus 2. And then you divide it by 2, right? Because then now you have 3 digits, you want 2. And minus 2 plus 1 over 2, right? Let's say you have 4 digits. I guess you don't even need this as a special case anymore. But let's say you have 4 digits. This is going to be 2 plus 1, 3. No, 4 digits. 2 plus. Oh yeah, that's fine. 4 extra digits. It's going to be 2. Okay. So then, yeah. So then now, yeah. I don't even know when this is true, actually, now that I think about it. I think these are wrong too, right? I think these are wrong. I think you just have to get the last digit and guess, which is the same thing that I'm doing here. Because it's not that the 999s are wrong, but it's the 888s. For example, this one. Well, it has to begin with an 8. This is fine. This may not be fine. Maybe it's fine. I don't know. I don't think that's fine actually. Because you can have because the middle digit is changes by 2, right? I don't know. Alright, let's just focus on the 7 for now, and then we'll focus on it. So you have this thing. As a property of 0, we know that this should be good. Okay, and now maybe we have 3, 7. Okay, 4, 7, 5, 7, 6, 7, 7, 7. And 6, 7 is clearly wrong. Because it only has 5 digits. Oh, this is only for odd number digits. Okay, If n mod 2 is equal to 0, then we do this thing. Yeah. Okay, at least now it has enough digits and should be okay. Because we optimized for this number. Okay. Am I confident? Honestly, not really. I'm gonna try this for... Okay, 8, 7. It should do the 9999 thing, but let's say we just remove this because it should be equivalent. Okay, so that's good. We don't have to. We could remove it, but let's say we have 4. Let's go over all of these. Now, the k is equal to 3 makes sense. Now we have to do this thing for 4. And we know that the last digit has to be an 8. Yep. Okay, so then now we try, what is it? 10, 4. Okay, there you go. See, you would have gotten it wrong, Larry. Okay, so then now, so this never happens. 2, I think this is still right, just because. Okay, so 5 should be right. 6 is not looking good, actually. So let's do this. This is kind of terrible because, as you can see, this is just a for loop. But yeah, okay. 1, 6, 2, 6, 3, 6, 10, 6, 11, 6. Okay, so 6. It looks actually pretty good with the 9s, but maybe not. Maybe I'm just a little bit lucky. But either way, I mean, the code seems to work, so I'm not gonna complain about it. 8 is definitely a thing as well. This should be a for loop. I need to clean this up, but okay. 1, 8, 1, 8, 2, 8, 3, 8, 4, 8, 5, 8, 6, 8, 7, 8, 9, 8. Alright. 8, 8, 8, 8, 8, 8. Ooh, see? 1. Okay. Am I Gucci? 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's YOLO. If it times out, that means that something is really funky. But it shouldn't be because of the pigeonhole. Maybe. Ooh, okay. Oh, this is dumb. Yeah. I didn't know about this because that's what I have. This doesn't make sense. Why would this be right? The 7 is wrong too. Okay. Because the last digit should be a 9. Yeah. 8 has to be even, that's fine. But the 6 doesn't make sense. May even be a 9, really. Is it 9? No, it has to be even, Larry. 5, 6 is okay. In 9, 8, okay. Yeah. I don't know. I mean, it's too much to check. Okay, let's double check the last digit. It has to be even. Odd, it should be fine. Alright, YOLO. Like I said, probably getting 5 wrong answers from this one. And 7 may be a little bit sketch, honestly. I don't know why I had a 7 in there, but that was wrong anyway. But this may time out with a 7. I could see that timing out with a 7. Huh. 4, we did 8, right? So we start with... Did I mess this up? Oh, typo. This is why I should have had a for loop. Okay, well, it's too late now, I suppose. Too much copy and paste. All right. Still may time out in this. This I am just making a lot of silly wrong answers. Okay, 19 and 4 is an interesting one actually. Is that consistent? Okay, so that means that 8, 9, 9, 9, 9, 8. We cannot do this one. Okay, so I was wrong in that. I did know this because let's say this is 8, right? So then now each change may not change the thing because every time we subtract, it's not good. So then now we need to, if, okay. I mean, there's so many things that I don't even know anymore. Okay, like I don't know what the right answer is for them anymore, but sorry, it's not very good for it. Okay, so basically the idea here is that each change is going to be, so okay, so each shift is equal to one. Okay, if n mod 2 is equal to 0, then each, let's say it's odd, right? Then each shift is going to be equal to 1 times 10 to the n minus 2 over, okay, so let's say this focus lab is the 5 digits, then it's just 100, right? If they're 5 digits, it's 100. So it's just n over 2. If there's 6 digits, well, it's different anyway. Okay, so just n over 2. Okay, else then, if it's even, then let's say there's 6 digits, then it is just n over 2 for the 100, and then plus n over 2 plus 1, something like this. Right, so we print n shift. Let's remove this for now. So then we have 4 4 5 4 6 4 7 4. Right, okay, so this is not right. Oh, because this is n. We need n minus 2. Okay, where's my force? D is equal to n minus 2. Okay, so if it's 4 digits, that is right. 5 digits, this is wrong. This should be 100. 5 digits, we divide by minus 2. Oh yeah, because, okay, fine. Okay, so then now it's 100. 6 is going to be okay, I think that's right. So that's the shift. So as you can see, This just doesn't work for 4. How do I even get an answer for 4? Oh, did I just get lucky? I think I just get lucky, right? What? Oh, because this is you shift. And then eventually you move on the next digit. Okay. How do I generalize this though? Okay, yeah, we're fine. If shift mod 4 is equal to 0, then we want to shift the next digit, and by so that this would be minus 10 instead. Maybe, I don't know. Right. Does it work for 19.4? Yeah, it worked for 19.4. Very slowly though. What is the slow on? Is it just on the 19.4? Wow. So this actually goes a lot of digits. So that means that if we have something bigger, then we don't get it. I think all the other ones are roughly right. Is it true? I don't even know if it's true. Let's see. Okay, so maybe I can do something like this, right? So okay, and shift, right? So then now maybe we can do a while loop here instead for the delta. What did I print? N and shift. What? So 19, this is whatever, 20, this is also whatever. Okay, so then now maybe, okay, delta by 10, then shift is so it's what? no, we want to shrink. No, then this. Well, let's see if this works first. I don't know if okay, so if this is odd, then it's going to be just, I guess it doesn't matter if it's odd anymore, I think. Right, just minus I plus this thing. Okay, so this definitely works for even. It's going to take 10 seconds, so let me think about it just once. If it's odd, it's going to be okay. 88 is always working, right? So okay. I think I don't need to do something that, because 88 as a suffix always works because it's singular on 100. Okay, so then maybe we can do something instead of all this stuff, all this shifting business. Here we just do a 10 loop, right? Okay, and then if this doesn't work, then we start with the other prefix of A8, and then now it's -4. But we have to be a little bit careful. Also, we have to do an n equals 1, right? Huh, I missed that anyway, so that would have been the wrong answer. If n is equal to 2 times n, right? So then now, yeah, so if n is equal to 3, this should work anyway, so we should try that, but I think this should be good. I don't know, return just 8 times n because I'm as a default. Yeah. Okay, so now we have some answers on this, and then yeah, okay, let's give it a YOLO submit. Just do I want a YOLO submit? I have so many YOLO submits already. Alright, whatever, YOLO submit. Just I'm so tired on this one. I'm gonna get a wrong answer, but hopefully it's an illustrative wrong answer. How many wrong answers have I have on this one anyway? I pre-estimated 4, but it seems like maybe more. Okay, so same thing with 8, so I'm pretty bad about this one. 8 also is 1,000 actually, right? So a single, okay, so yeah. So 6 is good because, yeah, 10 doesn't matter. Wait, what? 6, I have to think about a 6 case. 6, well, let's, also I keep forgetting to write, I mean, this is also wrong anyway. Oh, alright, let's just write if n is equal to 1, then we return, oh no, I can't do that because it's different for these. Alright, but if n is equal to 1, return 8. And also if it's just less than 2. Okay, and then now here we have the same idea, right? So because except for 8 it's going to be 1,000. But what is the thing for... I don't know how to do 6 though. I think 6 is maybe wrong, but can't prove it. Yet. Okay, I think this is just same as here. And then make sure it's marked by 8. Yeah, this is pretty fast now. But 6, I don't know how to do. Honestly, I think 6 is wrong, but I can't prove it. 5, 7, 7 maybe. I mean, it's the same logic as 7, but 7 got the... So why is 6 different than 7? Well, we're only worrying about time limited, and time limited is because this gets to cycle link lit before 1,000. Or if the... Oh yeah, if the shift... Okay, yeah, okay. Now I get it. Oh. What does this say? I should test that, I guess. I didn't know that that's a big thing. But, use what? Sys.set. I guess I should test this case. I actually forget. Okay, fine. Okay, that's good. And then we also want 4, 5, 6. I guess I should test this in any case, to be honest. But okay, it doesn't even print out that many things. Alright, let's give it a YOLO submit now again. Come on, baby. I always forget this thing though. Alright, that was that took forever. Did people get Q4? Okay, people got Q4. 175 people got Q3, and I have 5 wrong answers, just as I predicted actually. So I guess that's kind of cool. People are very fast though. I mean, this is going to be a disaster anyway. Yeah. Okay. All right, let's look at this one. 69. People got it. Nice. 40 minutes. Let's focus. Whew, that was a tough one. I had to kind of take a mini mental break. But okay, so how do I do Q4? So one of the things has to be less than K. So we can pre-process with respect to K. Can we do something on string length? Maybe. That Q3 took too much out of me. Like that was tiring. Okay, I mean, it has to be something with prefix sum, I suppose. How do I do the math on prefix sum? At most k, what does that mean? Can I do something? Let's say k is 1. So then now the sub thing is just all gonna be right. I guess that's fine. Or k is something big. What's my Q1 again? I guess I just did 4 loops and took a long time about it. Honestly, I feel a little too tired for this one, but all right, let's say we want to do the entire string. How do we get it? So on this, we could binary search to the left and then binary search to the right, or binary search to the left to get it for each thing, right? So that now we can say, okay, so that's the, so if we do it per character, we can do it for the entire thing. But then now, we cannot do, we can do some, can I sum it up in a smarter way? Okay, so then now each character contains the max to the left that it can go. Right? That's fine. We can binary search for that. That's gonna be n log n with a prefix sum. Okay. Oh, to the right, it doesn't matter. And then now for a query, we want to sum over all that, but basically doing a chop operation on the thing. How do we do that? We want to do a chop operation on thing. Square root decomposition. 10 to the 5th is a little bit big for it though. What is square root of 10 to the 5th again? Like 225 or something? 316? Am I thinking of something else? No, whatever. So 316. Can I do a square root down? I don't even know if I could, but I'm just doing the math on whether that's even fast enough, and I don't think that is anyway. Let's say we pre-process it that way. Then how do we... Oh, we can just think of them as segments. And then we count the number of intersections of those segments. So we do a sum. No, but it's not even the count of the segments, it's the number of them. But we can do a second query to it, so I guess it's doable, maybe. Maybe. No, because then now you have other ones that comes before. So you have to figure those out too. unless you tick all of those. No, that doesn't make sense. Okay, can I go further with this segment idea? Can I go for a segment? Yeah, I don't know if the segment idea works. This is gonna be terrible because I just have 5 wrong answers on this whole thing. But 100 people's gotten it though, and even more as we speak. People's got it in 10 minutes. I mean, they're smart people, but can I pre-process the queries? I guess that's the thing that I always forget. There are a lot of queries. Okay, let's say we want to pre-process the queries. That makes it slightly easier, maybe. This the 2 and 3. Oh, the 2 and 3 is considered. So then now, because then we can update the answers to the but then they have the right side, and the right side is a little bit awkward for sure. Especially if you have like an infinite number of them, almost a big number, and you have to update each of these, and if you have to update each query, then it's only n times q. Like my case is if you have 0, 1, 0, 2, 0, 3, dot, 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 that would be, and k is something big, then you would have to update all of them. And don't we have an idea yet? How many people's gone Q3? A lot of people's gone Q3, and I have 5 wrong answers, so that's a not good. Any other things I can notice? Q3 should not have taken me that long. Okay. Yeah, well. With each number we can extend how far it goes. All right. Okay, let's say we have segments and then we just do all the queries together. And then we can do, okay, maybe we can do it that way. I just am a little bit dumb about it. Okay, fine. Let's go, let's say, I think this is a good idea actually. So maybe I don't know if it's good enough, but it's a good place to start. Right. So now we have no, well, I see, because then you sweep them all together and then you only care about them. Is that true? Is that right? These line segments, okay. So you have like multiple levels of line segments, okay. You want some of these. That's the thing, you only want a subset of, so you don't want it to go extend, right? Like I feel like I'm close, but I don't. It's just so tough. Okay, let's just go for it. Let's just do the part that I know first, right? Whatever, prefix 0, prefix 1. Yeah, new mistake of doing it with numbers. Okay. Right. Okay, and then now we have events that are from sweep line. So okay, now just binary search, right? Okay, fine. Whatever, it doesn't really matter. So then now we want to binary search, okay. Yeah. Now we want to go to the right. We want to go something smaller. This is not L, it's I, which is actually confusing, but okay, fine. Okay, so this is good. So then we want to make the bigger array. So that means that we want left is equal to mid. Right. Maybe this is useful, I don't know. Okay. Why is that? No, this is inclusive bounds, Larry. Okay. So then now this goes only up to 4. Is that right for 2? Oh yeah, this is right because 6. Okay, and then everyone. Okay, so then now we have all these things. So 4 is going to last digit. So we can play around with whatever, but okay. So now you have all these segments: 0 to 4, 0 to 6, 0 to 6. All right. So this part was easy always, but then now, so 0 to 6 is just going to be you sum up all these. That's the thing, right? How do you even... Okay, so now you have n line segments, and each query we want to see what is the area under the line segment, almost. Is 0 to 4 the... Zero to 4 is only a 1 count anyway, but so we have to be careful about how to interpret this, but how do we do this without summing everything in a sloppy way? You know, let's say we have all these events. Right. Zero to 5 is everything, but 1 to 4. So now the 2 is from 0 to 2, so 1 to 4 wouldn't, so we only look at these things anyway. And then now you look at these things, 1 to 4, we get 9, because this is from 1 to 3. Is that right? That doesn't look right. Oh yeah, no, that's right. The code is better than I am. Okay, so 1, 2, 3. So then now you have 3 strings. Oh yeah, so number of strings. So I guess that's always going to be the. So that is the number of strings. Well, that minus the beginning. So 3 minus 0. The prefix is going to be 3. So that's going to be the answer. L minus plus 1. But then now, how do you get rid of the thing that goes beyond? Like we do 1 to 4. Some of these goes to 5, but we only cut it off at 4, right? And sum it all up. I don't know how to do it. I feel like I'm close with the idea, but I'm just missing one thing to put it together. I mean, unless it is just like regular segment tree. I don't think so though, right? How does segment tree work again? That's the part that I've always had, but I just want to at least get something down, I suppose. Because you're not getting the max, you're trying to get the sum, but this is the sum with a cap that is the parameter. We could have a lot of queries, and we're going trying to go left to right. Let's say we have 0 and then the 5. How does that? That means that it goes from 0 to 2. So okay, let's say we think of these as segments. Let me draw it out. Okay, so we have 0 to 2. We have 1 to 3. 2 to 4. 3 to 5. 4 to 5. And then just 5 to 5, I guess. And then now the 0 to 5 is just the sum of the entire box. Okay, I mean, I guess that's fine. 1 to 4 would be this, but then maybe I am dumb. Maybe that is the way to do it. Okay, fine. x is going to be x plus 1, right? And then we just sum it up. Right? I guess so. Am I just, maybe I was just being dumb then. Then queries. Okay, and then now we have this. Alright, so then now we have this. So then now we can just, I don't know, what is, maybe I am dumb. And I overthought it a little bit. 26, okay, so in 0 plus 5. What about 1 plus 4? 1, 2. 1 to 4 is going to be 1, 2, 3, 4. That's already 11, so that's not quite right. Right, so that's not, you can't just sum it up that way. And then 2 and 3 is 5, which I guess, no, this is wrong. And why is that wrong? Why is that wrong? Two, 3 should have 3. Am I just off by 1 indexing? That would be interesting. But these have 7 elements. Oh, well, I guess that's fine. Let's just write it. I don't even know anymore. So, it probably is wrong, but then that's fine. At least have something. I don't know that this is quite right, but right. Oh. Yeah, I mean, this is clearly wrong. That's what I thought, but I don't know. Why is this wrong per se? Because it counts stuff that starts before, right? So this 3 cannot be added because you have 2 starting from here. So then now we have to subtract stuff that started from before that. Okay, so then now 1. So that means that for 1 and 4, we have to subtract. Okay, yeah, I mean, this is the thing that I thought that I had running issue with. So for 1 to 4, you have to get rid of stuff that starts at 0. Maybe it's just maths in that way. It's just a sum and then, because then maybe it's just like math on double counting in all the regions. Okay, so we have this, it double counts this part. So we subtract the thing. 462 is not so. It's pretty bad. I mean, I should have gone. I should have gone there with fewer wrong answers. I don't. You know. I think I'm just still missing an idea, honestly. I knew that this. I mean, this was basically what I had in my mind for the last 30 minutes, anyway. So okay, so this is the stuff. This just has one contribution, right? But it's one contribution starting from 0. I see. So let's say we subtract 0. Would that be good? Not in this case. It's not enough still. Because the contribution, well... One goes to 2. So what does that mean? So then now we subtract the 0 things. Okay, maybe I have to. Okay, 3 minutes. Focus. Okay. Okay. We have 3 minutes. See if we can get it. Okay, so see we have 3. But no, but that's not even right, right? I have 11. So if I subtract all the ones that starts at 0, then I would get 8. Oh, because we have to add back in the one that starts inside, which is starting at 3. Okay, so let's do that first anyway. Okay, so then it's this minus the sum of all this stuff, so minus of start or something like this, right? And this should give me 8 and 0, but then now we have to kind of do the ones that starts inside but doesn't leave outside, so we have to add in, but that's the part that I couldn't get anyway, right? That's the part that I always struggled with. Is that the one that intersects, and there could be a lot of intersections with the endpoint. Try to do it fast enough. Yeah, I can't get it fast enough, and definitely not like right now. Let's see if I can upsolve this, but I'm gonna give it like so the contest is about to end in like a minute in case you're watching. I'm gonna spend like an extra 5 to 10 minutes, maybe. But this was the problem that I had all along. Like this was not new to me. I just don't know how to do it without, you know, in a fast way. other than having, okay, I think I have an idea. I think that's what I was trying to do before, but the idea here is just having these events subscribe to these things. Because basically we have here, so then now when we sweep, we go, okay, so then maybe we have a lookup is equal to right? Or maybe just events is equal to whatever. We listen to, right? And then now we want to listen to the right endpoint. So for SE and enumerate queries, and then event sub E dot append the endpoint, we append index. So we have to do that. And then now on the sweep, we know how many things matter. So then now for E in events sub I, then for index in E sub I, then we can have lookup of index. We want to subtract total sub I, something like this, and then we can do here to subtract lookups of index, because then that'll give us the prefix, right? Something like this. Lookup sub I, total sub I, key error 0. Key error 0. Which one? Key error 0. Oh, because I'm doing this. It should be collections counter, say. My brain is fried. 18. Okay, so lookup is gonna be negative. So okay, fine. Okay, maybe it's a little bit. Maybe it's before. Maybe it's just off by 1. I'm not sure, but I think this is roughly right. Maybe not. Where's my lookup thing? Let's print out the lookup for a second. Because basically this is saying that it may be off by 1 though, because this is off by, this is a thing, yeah. Still wrong, because we subtract too much. So okay, this is negative, which is fine maybe. Okay, for example here we have at okay, so then now we have these things, and then now we have a sweep, right? Is the sweep one? I'm a little bit just trying to see what works, which is not great, honestly. But okay, so lookup is fine. Index 0, 1, 2, so -3 on what I had. Right? Why? Because 5. It should be here. Maybe this? I don't know. We want to listen to it after it ends, and it's inclusive, so I think this is right, but I think this is a little bit wrong. I don't need to subtract anyway, so let's just do it this way. It's a little bit more what I am thinking of. So at 0 this is 6, that's wrong. I think this is now I, not I plus 1, but so 0 is 0 because that's 5. At 4 there's 3 things starting out. Is that right? Is this right? The 4 is 3. Let's see, I actually drew this. At the 4, wait. I want to print total, that's what I wanted to do. Okay, so then now, oh, no, that's right. Right, so then now it has 0 to 1, okay. Is it inclusive? Yes. Okay. So that means that at 2, okay. So okay, yeah, so it leaves at that one. That's fine. Maybe I'm off by 1. But there's 3. So there's 3 things inside. Is that true? I guess so, because it just goes to the end. Okay, so 1 goes to 2. 2 goes to 3. 3 goes to 4, right? So why is this 3? What does this 3 mean? Oh, 3 is just the number of segments inside, which is probably true, because then now, because our right should be whatever. Yeah, so I don't know where this 3 comes from. What's this total? 0, 1, 2, 3, 4. So then this 4. So you have 3 segments leaving it, but oh, we have to do the start part as well. I see. Because basically we and this is not just the number of segments, it's the sum of the things after the segment, right? So that's the part that's a little bit tricky as well. So I don't think this is right anyway. As is. Because total is just the number of segments, not everything after those, what these segments do. Which is the issue that I had in to begin with. Okay, yeah. This isn't quite right then. Yeah, can I adjust this to be whatever? Okay, so let's say we have these events that we want to listen to. And now we have this sweep, right? And we don't know how, without keeping track of the index, which we really don't want to do, because that'll make it n squared. Or n times q or whatever. Yeah, I don't know. I guess I'm missing something in trying, or the way that I'm trying to do it is a little bit too clever. The contest is over now. I'm trying to think about 600, yikes. But I mean, Q3 should have been doable. It is still tricky, but probably not a 5 wrong answer tricky. I just didn't think through all the cases. I was rushing a little bit. For sure. Q4, I don't want to click on it yet. I'm still thinking about it. Maybe this is a little bit too crazy. Because basically, we don't want to just count this. I mean, we undercount anyway, or we overcount anyway, but which is actually kind of. I mean, okay, we overcount probably just because I'm off by 1 somewhere. I think it's fine. But I think this is kind of. Did I change something? Why is this? Wait, why is this negative? Huh? Why is this negative? Why is this negative? It should be 0, nothing. This should be 0. No, I guess it's before we add this. Okay, fine. But then now we move to. No, I mean, I don't know how we got -3 on this one actually. I guess we removed some stuff from the beginning and then some stuff from the end. Yeah, I guess we moved too many things. I don't know. I don't know how to do this one. Let me see how long I can think about this. Oh, excuse me. Yeah, I told you to we will end up getting it. Yeah, and I also missed the case. I mean, there is a thing where like the ranges also goes from left to right. So there's so many cases with this. I don't know how to handle it. Quite all of them. I feel like I'm missing like one hint or something. Like we could also think about the queries, but and then for each one we can think. But that's the thing is that I don't know how to do it. in such a way that is not n times q. Because for each query, if we look at each cell, even as the events, I mean, I guess that's what I end up doing anyway, except for not completely. But and also the way that I did it is a little bit awkward anyway. Because if I did this sweep line, I didn't even need to do this kind of thing. I thought I could use this to get rid of some stuff, but if I'm going to do it this way, then it is also just the sum of all these, and like, I don't know, some part of this is just the sum of all this stuff, right? So it doesn't even make sense. And then we have to subtract out the extra stuff. Subtracting out the extra stuff is how I'm not I don't know how to do. Because basically you're just cutting it off, kind of. Yeah, I think I did more work than I actually was initially thinking anyway. But because all I need is the L total, right? We don't need, the way that I do it now, I don't need a lot of these things to be, because it would have been just incorrect anyway. So then now it's just the sum of, it's just the prefix sum, but then you have to, this is going to be, just for clear, I know that this is wrong, but it's like, something like that is basically the first iteration that I had, and I still run into the same issue. Yeah, I went into the same issue that I had with not able to chop things off. I know that there is an idea about querying offline, but I just don't know how to use it. Like if for each I we have to look at a lot of queries or even just some queries, then that's already not good enough, right? Like we use this to, I mean, it just becomes n times q. Like the start is fine, but then the ending. And the other thing that we were doing was trying to get all the segments. But the segments is not enough. Though yeah, I don't know. I feel like I'm missing a piece. Like I've been basically on the same idea since 20 minutes into this problem, and right now I'm already. Oh well, I don't have a counter on it. because that is on the entire contest. Do I give in? This is such a poor rank. Yeah, I don't know that I have a better. I mean, maybe it's just something that like as soon as I see it. All right, let's cheat for a second. Let's see if I could. I mean, this is the idea that I have. Well, a lot of this looks like the thing that I look at, so I don't know. M is equal to query. Kind of terrible naming, but okay, fine. I mean, that's fine. Okay, he did it with sliding window, I suppose, but yeah, I mean, this is basically what I have. I did it with binary search, but it's the same, I suppose. And then, yeah, I mean, it's fine. And then now, counts up by. Maybe I just don't know how to do math. So this is the length, and this is the prefix sum of the length. So I already have this, right? I pretty much have this is what I call L total. Right, so I do have this. So there is another binary search on the thing. I guess I didn't have this part. I just saw binary search, but LR is equal to, I mean, if low with mid, do we sort the input? No. Okay, so basically, this function is monotonically increasing, which makes sense because everything to the right. So then now, everything to the right of that is going to, I guess it's just formula is what he's saying. Everything to the right of that is going to be, okay, let's try it. I mean, I guess I just suck at math because I think I had this idea, but I just couldn't work out the math. I mean, I don't remember the formula really, so, okay. So maybe I have to try to figure out how to prove the math part about this. So left is equal to the S. Yeah. Right is equal to okay, so these are the ones where I'm still struggling with this, even if with this cheat hint thing, right? This isn't. So we're trying to get the first segment that has a thing, which makes sense, but I just don't know how to do the math from it. But maybe I'll figure it out. I was very close though. Maybe. I mean, everything else I've set up for a while. So okay. So if good of mid, and what is good of mid? If mid is if right of mid is then ye. So within those starting things, we try to find the first thing that is in bounds, I guess. So okay, so if oh, and this is terrible naming. Okay, fine. Let's just use LNO again. Maybe I just for this one, I guess I just didn't know the math, honestly, or the formula. What? I mean, this part I can do. Oh man, terrible namings. Okay, so that means that if the middle is within it, then we want it to be big. I think I like it the other way, where if this is greater, if the mid is greater, then we want the right to equal mid minus 1. All right, so then now L should be the last element with should be, or L should be the last element that is within bounds. L plus 1 goes out of bounds. Okay, I mean, this part I okay, fine, but I still don't know how to do the chopping, and I think that's where I just missed the math, which is this part, I suppose. So this part I literally have somewhere here, and then it's this, which is that if this is so, okay, so then now if L is greater than less than ye by the lingo, then how does this work? I think this is the formula that I don't know how to do. All right, we could work. Let's see if this works, and then yeah, and then we'll have to dissect it. I mean, I think this is L choose 2 or something, or like that number choose 2, but I don't know. I mean, this isn't quite right, unless I'm like off by 1 in some case, which is possibly true. And this goes out of bounds for some reason. I guess this is the way that he wrote this. If L plus 1 is the one that goes out of bounds. Yeah. Okay, so that looks better. But then now, because this is L plus 1, maybe this... I don't know if this is right, but... yeah, I don't know. I mean, everything else should be basically what he wrote. I mean, there is a geometric, like it's L minus R choose, or plus 1 choose 2. Maybe, well, it's the summation of all those things, I suppose. But I don't know how to get a... maybe my thing is wrong. Alright, instead of just trying to... I'm trying to reverse engineering this problem. I mean, I think most of my ideas are there. I just don't clearly clearly I'm missing missing the insight for this particular piece. It's either that or I'm just really wrong, and yeah, because basically, because in a funny way, like I did basically everything that he did. So I have this array, which is the same as this array, right? So yeah, look, so I did that, and then now this part I also did. So maybe we could just print answer, and here we could print result, and then I'd remove these. Okay, let's remove these. No, this should be. I just didn't want it, maybe. Okay, so the result is a little bit off, which is actually surprising. Their count. Oh, what is? Oh, huh. Okay, this is actually wrong or different. This is their L, so actually this is after the binary. Okay, that makes sense. Actually, I just didn't really think about it, apparently. But yeah, okay. So then now this matches except for this 3. Oh, should be the last time. That makes sense. I think this should be good. Why? Sometimes you have to, you know, grind it out. But I am still trying to understand this in general. Okay, so my L is different, and maybe because my loop is different. Is what I say wrong? L should be the last element that's within bounds. Oh, I see. Because I think I choose L as S, so I always have one item. So I guess that's why he has like this thing about this, which is actually a little bit awkward, but I guess it makes sense from that thing. Because then now we're able to go out of bounds. I mean, okay, fine. I mean, maybe I have to do something just like if right of L is less than or equal to E, then we do this, something like that. And then now this should be no. I mean, our L's are different, but that's fine in this particular case because this basically just checks the thing that he does with doing this -1. But but then now we have this formula, which maybe now that I did the other part right, maybe this is just right. Nope. I was also don't do E plus 1, so maybe that gives it an issue. Also in their case, their L plus 1 is different than their R, so R is actually L plus 1 already. So which is also kind of awkward, honestly, but okay, fine. Maybe it's this way. Nope. If L is the last element within bounds, I agree with that. If L plus 1. I don't know, but I don't know the explanation for this anyway, which makes it a little bit hard to debug because, yeah, even though everything else is roughly the same, I still like my binary search this way. Maybe this is a little bit awkward though, but I'm just double checking. I think this should be right, except for the different definition. This is R, or there are. Maybe there's some like weirdness. I don't know, but I still don't understand this formula to come up with it, because you have to figure out how far it extends, right? Oh, I see it. I see it. Okay, I see. I am dumb. I am dumb. I am dumb. I see it. I don't need their code anymore. Okay, I see it. Okay. Then now, it's that I changed it to this part that I realized, and then now, L plus 1 goes out of bounds. So from L plus 1 to Y, we have, I just didn't, this was the insight that bugged me the entire contest. That is, I was thinking about chopping things off the entire time. I didn't think about adding things on. Such an obvious insight, but okay, so we extend to Y. Right. So then now it means that we want to say, let's write a for loop just so that I am just yeah, just so that I can so Y minus I plus 1, right? Maybe I just want to get it correct. I don't know why this is still a little bit low though. Maybe my binary search is off because it starts at 2. So is 2 the? Am I right? Or am I wrong on this one? On my binary search. So we have L. All right. We have L. L is 2. So 0, 1, 2. Right, and it goes to 3, so we have 2 plus 1, but L is 2, so 0, 1, 2. That should, yeah, we should go from 2 to 3, right? So okay, then summing. Oh man, I'm missing this insight. Now I feel a little bit bad. Okay, summing. Okay, so I'm just really bad at this then. Okay, so Y minus I plus 1. Oh, this should be L. Fix this, but this is wrong. Why? And even this one actually. L should be L plus 1. Yeah, L plus 1 is the first one that goes out of bounds. Yes. And then this goes to L plus 1. But then now this doesn't work for some reason. From 3 to 3. Is that true? I thought L is 2. Oh, L plus 1 is 3. Okay, so here L should be the last one that's within bounds. This is why we add this. So then now, okay, 2 is the last one that is within bounds. I think that is correct, because then 3 extends to 4. So then now we should add 1, which is correct. But this part is not correct, I suppose. Right sub L, right sub L is I was having it off by once, but okay, fine. So 2, 3. Right sub L is 4. Really? Did I do this wrong? No, this is the last one that is inclusive. So okay, so 2, 3. Right? Yeah. L is 2. E is 3. Okay. So, but right sub L is 4. Why? I'm just having off by once, but I know how to do it now. I'm so dumb. I feel so dumb. Why is this 4? So 0 goes to 2 and 2. Okay, because the way that we store right. I thought I did it the right way. Where L is the last digit. Did I do this wrong? Did I do my binary search wrong? If both of these are right, then no, this should be right unless I did this part wrong, which is also possible, honestly, at this point. Yeah, maybe. Right sub I is, well, it's a little bit wrong because this should not be n-1 if you know, so this should be inclusive. So right sub I is for 0 should be not be 2, it should be 1. So that means that my binary search is a little bit wrong, right? It's k is equal to 1. So that means that is m plus 1 right? No, you have to be consistent. I did m plus 1 because I did from m to I. So if m is equal to I, then it's I minus 1. No, this should be right. Did I have some weird thing? I guess I'm just having two weird issues. Okay. Yikes. But I should have gotten this one, this contest. But I don't. Yeah. It's fine. Focus. I just missed one visualization. Okay, but I could still finish it, Larry. So finish it. Defend your honor. Why is this the? So we started I. Right. So that means that m. If m is I, then we have one element which is true. So why is this wrong? I think this should be n. Yeah, but that's what I saw earlier. Prefix should have n plus 1 elements though. I don't know why something is a little bit awkward. Okay, so if they're both, I could only be n minus 1, so this will become n 2 times n minus 1. If you do it by 2, it's going to be n minus 1. So m should be n minus 1 plus 1. So this should be at most n, right? So what is this giving me? Why is, I mean, I changed it to this because I thought that I wanted this, but then I changed it to this for this reason. But then I don't know why I'm going out of bounds. I is equal to n. This is right. This is right. Right. So, oh, this is wrong. That's right. No. This is right. Yep. It's not so bad. 788. Yeah, I mean that's what I thought. But then I'm getting complaints about this. Let's point it out. 7. Which part of this is it the I? M plus 1? Oh well, m plus 1 is 8, so 8 is not going to be good. But how did I get 7? 6 and 7, it's going to give 7. Okay. Do I have... I do have 6, 7. Okay, 6, 7, 7, 8. Is this m plus 1 or m? No, it should be m plus 1. No, the default should be 0 characters. Okay, fine. Okay, fine. So then now, is the right what I expect? Right is... Is 3, 0, 1, 2, 3. So this is just wrong. Okay, that's what I feared. Oh, no, this is right. This should be n plus 1. Or, yeah. If this is exclusive bound, it should be a little bit better. This is neither. I think this is more right, but then now... Okay, focus. What does this mean? What is m? M is the inclusive bound. If it's inclusive, then it should be m. No, you want to include it, so I don't know why this is wrong. You want to go for, so you have bounds of 6 and 7. So it's 8 minus whatever. Don't I have 8 things? How do I even get to 7? Oh, because of this n thing. Man, I suck at binary search today. Okay, but this is still wrong because this is now exclusive. 3 is it's exclusive except for these parts, which is now inclusive. So that's where I'm having issues, is that my binary search is just very awkward. Because it's not consistent. Yeah, 0, 1, 2, 3, 4. So okay, so that's good, but that's inclusive. Well, this is inclusive, but then this is exclusive from 0 to 2. Why? K is 1 on this one. Oh, no, you're an idiot, Larry. Okay, no, this is good, Everything's inclusive, it's just 0, 1. This is a valid string, I just confused. Yeah, because there's only 1, 1, so this satisfies, so this is good. Okay, so all this time I'm just being silly. Alright. Debugging the wrong things. Okay, so like, I'm usually pretty good at binary search, at least on this stuff like this. That's why I was so confused. But okay, so that's right. Okay, so then now let's check our homework again. So then now we have from 3 to 4. For which one? I already kind of lost all my... I'm confused these days. Okay, LE is 2 to... Oh. It's not LE, but okay, fine. SE and then L. Put it that way. Also, don't we print this? Okay, I guess so. Okay, so from 1 to 4, so this is the input. We have 2, because... Okay, let's just print out right, just in case our binary search is not correct. Okay, so we have this thing. We want to see the first instance. So L should be the first instance that's, or the last elements that within bounds. So that means that from... I spent like an hour on this. Today's just not my day, I suppose, but that's fine. Okay, so so then L is 2, so that means that this is 4, and this is the last element that's within 4, which is correct. So then now what? 1 to 4 is going to be 9. I guess this is the right one, so I don't have to look at this one actually. 2, 3, 2. Okay, so then that means that the L is 2. That's not correct. Oh, is my binary search dumb? No, it's just that it's just that the first one goes beyond that, so this should have, yeah, so this doesn't do anything, which is what we should expect, because yeah, right, yeah, so this is what we expect, but the 1 is not what we expect, so we start from 3 to 3. Oh, because the L is 2, but it doesn't count the fact that L can be smaller than the starting. So we count L plus 1 for some reason. Because L, this is not technically true, because L doesn't have to be in bounds. So if L is not in bounds, then we just L subtract by 1 to make it out bounds. Then we get the entire thing, and then there we go. Okay. I am yeah, it's a little bit awkward, but let's get it correct, and then we'll clean it up afterwards. So then now you have this, right? This looks good. I'm gonna submit it. I know that this is wrong because it should time out, but I just want to get a timeout, because if I get a wrong answer before the timeout, then we can fix it. Actually, that's actually hilarious. But oops, how long does it take anyway? 2 seconds. So we didn't even have to fix that, but we should anyway. But that's kind of okay. That makes me even feel a little bit worse. But yeah. So this is just yeah, there are 2 ways to do it, I suppose. So this is just sum from 1 to e plus 1, right? So sum from 1 to e plus, or 1 to e, sum from 1 to e, which is going to be, I always forget this. So 1 is going to be 1, 2 is going to be 3. So it's 2 plus 1 over 2. Okay, so e plus, or e times, yeah, e times e plus 1 over 2. And then, so subtract by, now we want to subtract out everything less than L. So it's just L times L plus 1 over 2, right? So something like this. Yeah, the comment's a little bit confusing. Let's just see if it's right first. Okay, that's wrong. Why is that wrong? Well, so we want to go to L. So we subtract everything from L. Right? So 1 to L. Oh, no, the inside formula is this, it's not, okay, so then now it's e minus I. Okay, so I messed up on this formula. What am I doing? Okay, so then now now we have e minus L plus 1 plus dot 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 plus when e is equal, when I is equal to e, this is going to be 1. So it's 1 plus dot 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 plus all the way to this number, right? So then now it should be basically what the other dude did, which is e minus L plus 1 times this plus 1 over 2. I know I wrote it in an intentionally confusing way, but it So it's this number plus, right? Why do I? So the result is E. It is going to be 1. If the result is L plus, oh, this is inside, so okay. I think this should be this, which is why there's a confusion. Okay, fine. So then here, and then here. You used to mess up when you do it too quickly, and also I had to comment this out. You used to mess up when you do it too quickly. Let's give it a submit. Okay. Yeah, overall not a bad problem, yeah. This is just me being dumb. I should have gotten this one. It's just, I mean, yeah, no excuses. It's just me not handling this one. Yeah. I'll go over this later, but yeah, terrible contest for me, but it is what it is. That's all I have though. Thanks, props to RVRTY5, I guess. I just kind of, such an obvious thing in retrospect, but I guess everything is obvious when you know the solution. So yeah, I had this in, yeah, I had such close things, but yeah, that's all I have with this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.